Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The Third Room by Wiggle, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. And we have numbered rooms clues, where clues outside the grid indicate the digit which has to be placed in the nth cell in the corresponding direction, where n is a digit placed in the first cell in that direction. So, for example, if this were, say, a 6, that would mean that the 3 has to be placed in the 6th cell in this direction. So, therefore, that would force this to be 3. And that works with all the 3s that are outside. There's also one 9 outside. But again, remember, n is basically the digit in the first cell, and then the number outside, or the digit outside the grid, must be placed in the nth cell, where in this case, again, it's 6th. If this were, say, 4, then 3 would have to be in the 4th cell going in this direction, which would mean it would have to be here. And those are examples of how numbered rooms works. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Or, sorry, let's learn how to Sudoku. Sorry, I'm a little out of it right now. Anyways, yeah, let's do that. Let's learn how to Sudoku. Okay, so the thing is about numbered rooms clues. If you have the same number outside of the numbered rooms clues, you know, first of all, in a numbered rooms clue, unless the outside digit is a 1, there's no way you can have a 1 in any numbered in the first cell of the numbered rooms clue. And that should be obvious, right? Because if you placed a 1 here, that would say 3 has to be in the first cell in this row. But we already have a 1 there, so that's obviously not possible. Oh, I feel like I need to sneeze. So 1 can never be in a cell, in the first cell, unless, for a numbered rooms clue, unless it is, the clue outside is a 1. And the second thing is, on a numbered rooms clue, you can't have the same digit, unless it's a 1, be the first digit. Because if we try to make this a 3, that's saying 3 has to be in the third position. But obviously it's in the first position, so that's a contradiction. So in all the 3s that are numbered rooms clues, you can't have a 1 or a 3 ever be a numbered rooms clue, right? So because of that, these digits have to be the digits 2, 4, 5, 6, 7, 8, 9. Right? So this has to be a 1-3 pair, which means the 3 has to be either in the third position, which it can't, or the 9th position in row 9. So therefore, it can't be in the third position, because again, if this is 3, that has to be 3 also, and then we'd have a duplicate in the row. So this must be 9, which makes this 3 and this 1. So 3 is in the 9th position here. That means also 3 has to be in the 9th position here. So this is 9, which means this 3 has to be in the 9th position in row 1. So this is 3 here. So that eliminates 9 in the rest of row 9. Also, yeah, this 9 clue says that 3 has to be in the 9th position here. So, okay. 3 here cannot be 5th. Also, if you have two numbered rooms clues, which are in the same row or column, obviously, those 2 digits must add up to 10. Because what's in the second direction this way is in the 8th direction this way. What's in the 3rd direction this way is in the 7th direction this way. Same with 4th and 6th, etc., etc. However, what you cannot have is a 5, right? That's the only, because you have 5 and 5 in the same column or row. If the number of rooms clues outside the box, outside the grid, are the same. And then again, you can't have a 3 be one of these number ends. The end cannot be the first digit in any of these numbered rooms clues. So you cannot have a 5 here, and these correspondingly have to add up to 10. So it's 2 and 8 with 2 and 8, 4 and 6 with 4 and 6. You cannot have a 3 here, because again, 3 would say 3 has to be in the 3rd position when it's obviously in the 1st. So this can't be 7 here. So this is the same thing. This must be 2, 4, 6, 8. This must be 2, 4, 6, 8. And this must be 2, 4, 6, 8, because again, you cannot have 3 being in the 7th spot here, because that would be 1, 2, 3, 4, 5, 6, 7. It would be the 3rd spot here, which is obviously not allowed. So we have a 2, 4, 6, 8 quadruplet in row 1 and row 9. That eliminates 2, 4, 6, 8 in the rest of the row. So it's new 2, 4, 6, 8. This is 5 or 7 here. This is 5 or 7 here. This must be 5 or 7. And this must be 1, 5 or 7 or 1, 5 or 7 here. That means, where is the 3 in... Well, where's the 3 in this middle row? The 5 that corresponds to one of these 3 means that the 3 has to be one of these 2 here. Or there could be a 3 going this, a 3 being here. So in column 4, the 3 has to be either in 3, that's 5 away, or 7 away here. So this would be 3 or 3. This would be 5 or 7 away. But if there was a 3 here, these would both have to be 5 as numbered rooms clue, and therefore you'd have a duplicate. So this cannot be 3 here. Therefore, this is guaranteed to be 3 here, because there's no other place for this 3 in this column. So this is 5, this is 7, this cannot be 3, which makes this a 3 here. So that's 4 away going this way, and 6 going this way. So that's 4 and 6. The 3 is 5 going this way, so this is 5. This cannot be 5, because if this were 5, 3 would have to be here, and there'd be a duplicate, so this is 7 here. This can't be 5 or 7, it's 1. This can't be 1 or 7, it's 5. This 7 means that the 3 has to be 7 away, so this is 3 there. This is 9. This digit, so where's the 3 in column 8? Cannot be here because of the 3 in the box. Can't be here because of the 3 in the box. So it has to be one of these 2, which means this becomes a 4-6 pair. And, right, because if it's here, that's 4 this way and 6 this way. If it's here, that's 4 this way and 6 this way. And we know this can't be 6 because of the 6 in the box. So this has to be 4, which makes this 6. So 3 has to be 4 away from here. Therefore, this must be 3. This can't be 4. That eliminates 4 in the rest of this row and 6 in the rest of this row. So 3 is here, so that makes this a 2 and this an 8. 3, where's 3 in row 2? It cannot be any of these digits because of the 3's in the box, so it must be in 7, 8, or 9. It cannot be 9, so this is 7 or 8. This can't be 7, so that makes it's in the 8th cell. So that means 3 has to be there. Okay. 3 is the 7th cell here, so this is a 7. And again, 3 cannot be in row 8 in any of these cells or any of these cells because of the 3's in the boxes, so they have to be, cannot be here because 3's in the column, so this must be 3 here, which makes this number of rooms clue be a 4 to be 4th in that direction, and 6 to be 6 in that direction. And again, these add up to 10 because of that. Remaining digits remaining digits in column 1 are 1 and 2. 3 has to be here in column 6, so this is 2 this way, and 8 this way. So this cannot be 2 here. This cannot be 8 here. This is a 2-6 pair, which eliminates 2 and 6 in the rest of the box, so this can't be 2. This is 1, that's 2. 3 here is 2 away, so this is the second one. That must be 6 then. This is 8 away, so this must be 8, and that's a 4. And again, these two add up to 10, etc., etc. So 3 must be 6 away from here, so that means it's here, so that's 3. We should have all the 3's now. We do. Okay, remaining digits in column 9 are 1, 5, and 7. This cannot be 5. This 3 is 7 away, so this is 7, which makes this 1, which makes that 5. So that's saying that the 9 has to be 5 away. So this must be a 9 here. And that should be all the information we can get from numbered rooms, because we have filled in the entire border. And we've filled in all the 3's. We've filled in the only 9 that we have numbered rooms clue for. So that should be done. So now the rest of this is just normal Sudoku. Where is 8 in the upper left-hand box? It cannot be here. It cannot be here, so this must be 8. Remaining digits are 5 and 7 in that box. Where do we have the most digits? We don't have that many. Okay, digits in the lower right-hand box. We have 2, 7, and 8. 7 cannot be here or here because of the 7's in the row in the column, so this is 7 here. This becomes a 2, 8 pair. Digits in this lower left-hand box, we have what? 1, 2, 5, and 9. Not 7, 9. So this can't be 5 or 9. This becomes a 1, 2 pair. 2 eliminates 2 here as a possibility, so this is 1 and 2. This cannot be 1 or 2. It's a 5, 9 pair. This 2 eliminates 2 here, so it's 8 and 2. Remaining digits in row 7 are 4 and 6. And 6 cannot be here because 6 in the column, so it's 4, that's 6. Remaining digits in row 8 are 1 and 8. 1 can't be here because 1 in the column, so that's 8 and 1. Okay, we have rows with 5 in them. Okay, let's do the column 3, rows and columns with 5 in them. Let's do column 3. It can only, the remaining digits are 1, 5, 7, and 9. This can't be 5 at all. And this can't be 1 because of the 1 in the row. So where is the 1 in column 3? It has to be here. So that's 1. We have column 4. Remaining digits are 2, 4, 8, 9. Okay, 2, 4, 8, and 9. 8 can't be here because of 8 in the row. 2, 4, 8, 9. 2 can't be here, and 8 can't be here because 2 and 8 in the row. This can't be 2 because of 2 in the row. Okay. Remaining digits in column 5, we have 2, 4, 6, 7. Okay, whereas 2 cannot be here because of 2 in the row. This can't be 2 or 7, or 6 because of 2, 7 in the row and 6 in the box. So this must be 4. This can't be 4 or 6 then, which must make that 7. So this cannot be 4 and 7. This becomes a 2, 6 pair. This 6 eliminates 6 here, so that's 2, which makes this 6. That eliminates 2 in the box, so this is 4, 9. We have a 4, 9, 4, 9 pair, which eliminates 4 and 9 in the rest of the row. This cannot be 4 or 9, it's 8. This can't be 4 or 9, it's 2, or 8, it's 2. This 4 eliminates 4 here, so it's 9, which makes this 4. Okay. We have digits with 6 digits already set in them. Let's go with row 4 then. It has to be 4, 5, and 6. This cannot be 4 and 6 because of the 4 and 6 in the column, so this is 5. So this is 4, 6, and this is 4 or 6. We have 6 digits in column 6, so the remaining digits are 1, 7, 9. 1 can't be either of these digits, so this must be 1 here. This has to be a 7, 9 pair. We have 6 digits in row 6, which means the remaining digits are 5, 6, and 9. 5 cannot be here, so this is 6 or 9. 5, 6, or 9 are here. This can't be 6 because of the 6 in the column. Okay. Remaining digits in row 2. We have 2 has to be one of these, and 2 cannot be here, so 2 has to be there. This cannot be 7. It's 5, 7, and 9 remaining, so this is 5 or 9. Row 3, we have 1, 5, 7, 9 remaining. 7 cannot be here. This is a 1, 5, 9 triplet, but 1 cannot be here because 1 in the column, so this is 1 there. That forces this to be 5 and 9. We have a 5, 9, 5, 9 pair in column 7, which eliminates 5 and 9 in the rest of the column. This can't be 5 or 9, it's 6, which eliminates 6 here, so this is 4, which makes this 6, which makes this 9, which makes that 5. This 9 eliminates 9 here, so it's 5 and 9. It also eliminates 9 here, so it's 7. 5 eliminates 5 here, so it's 7 and 5. 7 eliminates 7 here, so it's 9 and 7. This 9 eliminates 9 here, so it's 5 and 9. And the rest is pretty straightforward. This is 4. We have 8 and 9 left. This must be 8, and this must be 9. And that's the solution. I hope I gave you some insight into numbered rooms, because that numbered rooms is fairly common as a rule set. So you'll see it every now and then. And it's good to know some of the sort of intuitions you can have, or deductions, I guess they would be, you can make from number rooms clues. Yeah. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.